So this part of the test, you're allowed to use calculators. So, like the first one here, this is an order of operations problem, but you're probably not going to want to put the whole thing in your calculator all at one time, so we still need to talk about order of operations. We have to do parentheses first, or grouping symbols first. I actually have two sets of grouping symbols. I have the squared off brackets, but inside the brackets I have the parentheses. So we have to start with our parentheses first. So 12 minus 4.2 is where we're going to start. So what is 12 minus 4.2? Let's see here. 12 minus 4 is 8, so that's what, I believe it's 7.8. Somebody might want to check my math on that. And so I've substituted 7.8 for the 12 minus 4.2, and now I'm just bringing everything else down that I haven't worked with yet. So I've got rid of my parentheses, but now I still have my squared off brackets, which is still a grouping symbol. So we still have to work inside our bracket, but inside our bracket we have a division and we have an addition. Which one comes first? The division. So 7.8 divided by 0.02 is 390. So we have 390 plus 3.5. We still have, and I'm just bringing everything else down that I haven't worked with. So we're just doing one thing at a time. I still have my grouping symbols, so I'm going to continue to work in there. 390 plus 3.5. So that is 393.5, and I still have the times 1.1 squared. So now all of my parentheses are gone, all my grouping symbols are gone, and I have two operations still. I have an exponent and I have a multiplication. What comes first, exponents or multiplication? Exponents. So remember, that means 1.1 times 1.1. That means 1.1 times itself 2 times. So 1.1 times 1.1 is 1.21. And now one final operation. I just have to do a final multiplication. And I get 476, let's see, do they want us to round it all? No. And it does terminate, because it's 476.135 is my final answer. So the first thing we did was we started working within our brackets. Inside our brackets, we worked inside the parentheses first, did that, then we did the division, then we did the addition. That got rid of all of our grouping symbols, and we had exponents and multiplication. We did exponents first, and then our multiplication was last, and our final answer of 476.135. Okay, so this one is a word problem. It says the same kind of water is sold in 2 types of bottle. Which type has the lower unit price? So we have 5 20-ounce bottles for $5.50, or 7 12-ounce bottles for $4.96. And they want to know unit price. So how do you think we're going to go about doing this? We're going to have to find the unit price for both, but we just have to decide how are we going to do that in order to compare which one's the better buy. Any ideas? Okay, so yeah, the first thing is we have to find out how many total ounces we're talking about. We have 5 bottles that are 20 ounces. In order to find a unit price, we need to know how much per ounce. So we don't have 20 ounces, we actually have 5 times 20 ounces. So that's going to be the first step. So I have 5 times 20 is 100 ounces. And the cost of that is $5.50. So I have 100 ounces, for $5.50. If we want to find the unit price, we want to find out how much per ounce. So what we're going to have to do now is take our $5.50 and divide it by 100, and that's going to give us how much money for a single ounce once we do that division. So $5.50 divided by 100. We get 0.055. In other words, it costs... Okay, so we had to find out how many ounces we were talking about first, because we didn't have total ounces. In order to find a unit price, we got to find total ounces. So we know that we have 5 bottles with 20 ounces in them each. So we multiplied to find out our total ounces, which was 100 ounces. And then that was $5.50 for 100 ounces. That's how much we're talking about total. So now we take our $5.50, which is how much we're paying for that, divide it by our total number of ounces, which is 100, and that gives us 0.055. In other words, if we think of that in terms of money, because it is money, that it's like 5.5 pennies, if there was such a thing as a half a penny. So what this tells us is that it's 5.5 cents for every ounce of water. That is the unit price. Now we have to do the same for the other type of water and compare, because that's the only way that you can compare prices when you're in the grocery store, is to look at how much it is per ounce. I don't know if you ever look at those tags where it says like unit price. I hope you do. If you're a bargain hunter, then you know what I'm talking about. And if you're not, the next time you're at the grocery store, don't just pick up what you think is the cheapest, look at the unit price. Okay? So let's look at the other type of water. We have 7 bottles that are 12 ounces each. So we have to find the total number of ounces. So we're going to multiply 7 times 12, which I believe is 84. That's how many total ounces we're talking about, and it's going to cost us $4.96 for 84 ounces of water. To find my unit price, take the cost and divide it by the total number of ounces. So $4.96 divided by 84 is, and this looks like we're going to have to round, 0.059. So the water that is priced at $4.96 is actually more expensive than the water priced at $5.50 per ounce if you look at their unit price. So to answer the question, which type has the lower unit price? The 20-ounce bottles have a lower unit price. So you're getting more for your money if you purchase the 5 bottles with 20 ounces. Otherwise, if you purchase the other kind, then you're paying almost 6 cents per ounce of water instead of 5.5 cents. I mean, there's not a big difference there, but if we're looking at unit price, the 20-ounce bottles are a better buy. Any questions on that one? Again, the key is to just be consistent. Oh, I guess I didn't see that one at the bottom. Okay. Number 9, we're getting into percent problems. Remember, the proportion is over of equals the percent over 100. So it's 117 is, so my 117 would go in the is spot. 45%, so my 45 goes up here, and the of is what I don't know. And now it's right back to the same type of problem we've worked the last few problems. I can multiply my 2 numbers that are diagonal from one another and then divide by the third number. So 117 times 100 is 11700, and that's going to equal 45x. Now, right here, do you see a relationship between the equation I translated over there and this here? Do you see a relationship? They're not exactly the same, but they are equivalent to one another. And we'll get the same answer for both. But in both scenarios, whichever route you decide to go, we have to divide to find our final answer. I have to divide this one by 0.45, and I have to divide this one by 45. And when I take 117 and divide it by 0.45, I get 260. And when I take 117 or 11,700 and divide it by 45, I also get 260. So this is why you could solve it either way. It just depends on which method you prefer. Now, a lot of people think that the proportion takes longer and is more work. But what I like about the proportion is it doesn't matter what kind of percent problem it is, you can use that. Okay, it looks the same. Is over of equals percent over 100, because there's 3 different types of equations or types of percent problems that you might see. The proportion works on all 3. So if you're translating, each equation might look different. But again, it's up to you, whichever method you prefer.